My ninth standard is on potential energy. I picked number 66 from chapter 6 under elastic potential energy. And this question says that you shoot a 51-gram pebble straight up from a catapult whose spring constant is 320 Newton meters. The catapult is initially stretched by 0.2 meters. How high above the starting point does the pebble fly? And it told me to ignore the air resistance. First, I drew my little picture, the catapult pushing the pebble up. And then I know the mass of the pebble. They gave me the spring constant. And I know my x. And I'm looking for how high it went. So it could be height or it can be my x final. And then I want to change my mass into kilograms, from grams into kilograms. So I did my conversion. And then my potential energy of the spring constant is equal to 1/2 k x squared. I know k and I know x, so I plugged it in. After I plugged the number in, worked it out, I came out with 6.4 joules. And then from here, the potential energy turned into kinetic energy. So this is my initial kinetic energy of the pebble, which equals, I found that equals to 6.4 joules, which equals to 1/2 mv squared. I know my mass, but I'm looking for my velocity. So what I did is I divided by 1/2 times mass to the other side, and I square rooted it both sides, which gives me V and of 6.4 square root of 6.4 joules divided by 1/2 times the mass. Plugged in my numbers, and then I came out with a velocity of 15.8 meters per second. And then this is since this is the velocity, I know that there's only two velocities. So to find the average velocity from this velocity, I divided by 2. So I got 15.8 divided by 2, which gives me my average velocity of 7.9 meters per second. And then I know the relationship between acceleration, velocity, and time. So to find time, I would have time equals V over A. A, in this case, since this is shooting up and down, the acceleration is 9.81 from gravitational force. So I have velocity of 15.8 meters per second divided by 9.81 meters per second squared. Meters per second cancel, which leaves me with second. I have 1.16 seconds. And then this is a relationship between velocity, distance, and time. And for me to find the distance, what I did was I multiplied t to the other side. So my distance equals, my final distance is 7.9 meters per second times 1.61 seconds. Seconds cancel, which leaves me with the pebble flew above 12.7 meters from where it was shot. And that is how you solve this problem on 66 chapter 6.